Everybody sign register? Alright, who has an understanding of what is a complex number?
Okay, so complex number is a real number mixed with a imaginary number. Let's say magic number.
Okay. Yes, so what is the definition of a real number? I don't know. Check that. I was waiting for that. Okay, but not really a concern. Your real numbers are anything from negatives going to positives. Negative 2, 5, 7, 1, 2, 3, all the way to 30. That's real numbers. Okay, imaginary numbers will have the j or the I with the real number with it, or just j itself. Right.
I think we believe it.
Complex number combination
Yes, sir. All time.
real and imaginary number. For example, we can use our normal with this is our real. This is our imaginary element. Okay. Another example can be 2 plus 3j or 2 plus 3i. Okay. So don't get confused if you see I. It's the same thing. They like to do that in the papers. They don't give you j, they give you I. And then people get confused, they don't know how to solve it. It's the same thing. Alright. Now let's talk about Argand diagrams. Very important. Argand diagram. Okay. So everybody knows what's a Cartesian plane.
Okay, so Jeffrey,
Yes.
he showed us.
Got it from you. Told me. Talked about this all the time. So you should know what's a Cartesian plane. Okay. So here on this Cartesian plane, our real numbers always fall on our x-axis. Okay? Our real numbers. Sorry, my R is good. Okay, and our imaginary numbers fall on our y-axis. Our imaginary numbers. Okay. So we got 1, 2, 3, negative 1, negative 2, negative 3. Here, it will be 1, j, 2, j, 3, j. Okay, sometimes they don't show the j's. You're just supposed to know that a y-axis has imaginary numbers on it. Okay. Negative 1j, negative 2j, negative 3j. Right. So, if they give you a Cartesian plane, or if you are looking at the memo in the doing your revision from past year papers, if they do not show the j's, they just got numbers there. It's because they already know that the y-axis is representing j. Okay, so don't get confused. All right. So let's plot something. A complex number, we can plot it on the Argand diagram. All right, and we're coming to a point now. Okay, so let's see, we got a complex number 1, 2 plus 3j. Complex number 2 minus 2 minus 3j. how would we plot Z1? Okay, these are our coordinates basically.
Yeah.
Perfect. Right, these
Yeah.
are our coordinates. You take the sign with the coordinates. Very important. Take the sign with the coordinates. So if you're plotting this Z1, we got 2 and we got 3J. That's our coordinate. That is Z1. Alright. Here we got -2 and we got 3 minus 3J. That is our Z2. Right. Now what do these look like to you?
Vectors.
Triangle. Pythagoras.
And we use Pythagoras theorem on what triangle?
Right.
Right angle triangle. Right. So you can see we've got an angle here, we've got an angle there. We have an angle here, but would that be a correct representation of it? No, it would not. Okay.
So you have to add 180 to it.
That's right. Jeff is teaching you well. That's good. Okay. So that's
No, he
basic.
doesn't add 180. He tells us to south, east, west.
Let me show you now. 180 now. Okay, so this is basically your Argand diagram, right? Let's show you something never seen before. Okay, so when we're looking at this form right here, this is called the rectangular form of a complex number. This form right here, where you see the real number and you can see the imaginary number. Okay, that is called the rectangular form. Now, one of the main things, well, actually, if I have to give you some advice, the main thing that they'll be testing you in the test is to be able to convert from rectangular to something called a polar form. Right? So if you can efficiently convert from rectangular to polar, you got 12 marks already. Right. So polar form, you take your rectangular form and you use an Argand diagram to convert it to polar form. Right. So for example, right, we have a rectangular form of 2 plus 3J. And we say we want it in polar form. Convert to polar. So let me give you the rules before we get to that here. The polar form method is Cartesian plane. We have the same resultant. Okay, we will label this R, we label this B, we label this A. Right, so we got our opposite, our adjacent, and our hypotenuse. Right, and we got our angle in between. The angle matters in polar form. Right, if we were to look at this right angle triangle, okay, cos theta is opposite over the resultant. Am I right? Opposite over the resultant. Cos theta is opposite over the resultant. And if I were to just represent A, it would become R cos theta, right? The same A here. Understanding? Understanding where I'm getting this A from?
Yeah.
Because it's a coordinate. It's a measure of the length. Okay? Lost.
Also lost.
You lost, also lost. Okay. So remember we had the Cartesian plane.
What is it that's supposed to be?
Hmm?
We were saying opposites. Opposites was the thing.
Sorry, adjacent I said. Because cos is adjacent to the resultant. Yeah. Yeah. So sine is opposite over hypotenuse, tan is opposite over adjacent. Okay. So remember I said these are coordinates. So it's basically, if you actually look at the Cartesian plane, it's basically this here. This represents your x, that represents your y, alright?
Yes.
Alright. So this is the same thing now. So A is our x. A can be 2, 3, 4, 5, minus 2, minus 3, minus 1. Sorry. Okay, this is your x. JB is your y. Can see that?
Yeah.
Okay. So we measure it in terms of length now. If A was 2, how long is this portion right here? From here to here, from 0. If A was equals to 2, it's 2 units. Am I right? Same thing with this here. What's the length between here and B? And if B is 3, it will be 3 units. Okay, so just like that, we're converting this into a right angle triangle using the Cartesian plane. Understand? So if we got B and we got A, we can calculate R using theorem of Pythagoras. Okay, right. So from using this information, I'm showing you how to convert it to polar form. Okay, so using this triangle right here, if I say cos theta, what's cos theta in terms of fraction? Adjacent over hypotenuse. Okay, so that's how I got A over R. Got that part. Right, and then if I manipulate this, if I cross multiply, I'm getting R times cos theta to represent A. Because remember, I'm trying to convert A to polar. I'm showing you how I'm getting to polar. Okay, this is the method. Right. So this is the first part done. If I were to convert B into a trigonometric ratio, I'll say sine theta is equal to B over Ry, opposite over adjacent. And if I cross multiply, B is equals to R sine theta. Right, but isn't B on the imaginary side? Right, so there should be a J there. Can you grasp that again? Right, remember I said Y is imaginary, X is real. If I don't show the J's here, you already know it's meant to be J. If it's 2, it's 2J. If it's 1, it's 1J. If it's 3, it's 3J. Grasp it? Okay, now because
the
B
is actually
B.
imaginary.
Right, so you have to put the J there to show. Right. Okay, now if I were to put it in my form, I've got a rectangular form of A plus JB. What is A? A is R cos theta. Right. What is B? Already showed B here. It's going to be R J
Sine.
sine. Understand? Okay. Now, cos theta and sine theta, we can show it as basically something called this, only in polar form. Okay? Only in polar forms we use this here. Right. From this form right here, we can say R SIS theta. That is a polar form. That is a polar form.
What?
Yes. It represents cos. I represents imaginary. S represents sine.
Oh. Oh.
I like that realization. Francis. Okay, right. Mainly we use this form right here. Okay. So we can go from here to here, from here to here, from here to here, from here to there, from there to here. That is what they test in the exam. Mixing it all up in between. They'll tell you what form I want it in. I want it in CIS, I want it in the rectangle form. Right. This it's just it's a polar form. You just know it's polar. Cis is also polar. Yes.
Repeat the sister.
C
Cos.
I is J. Remember J and I is the same thing. Remember, because mathematicians use that, engineers use J, and sine stands for S. Right. Now, what about our angle? How do we calculate our angle? Using the right angle triangle. We know one side, we know the other side. Since we got opposite.
10.
Yes. Yes. Okay, so we got tan theta is equals to B over A. Am I right? I'm not right.
Yeah.
Yes. Okay. And then how do we calculate the angle? You say shift tan in your calculator, the inverse. Okay. Understand? Below this here.
Yeah.
And then it's B over A, and you'll get your answer. That's theta. Okay. So the whole basis of your test will be using this Argand diagram, but you don't get marks for the Argand diagram. You just get marked for your Argand
So we have
diagram.
to do that.
You do this for your own understanding, if you can get it out, unless they state, draw the Argand diagram. Show us your Argand diagram, draw it, and then show us your calculation, but most of the time you don't get marks for this. You get marked just for doing this here, the cos, the sine, the tan, and showing your R. Now obviously you know your R is A plus B. Okay, alright? Right. Okay. Remember we have to calculate R for this. So that is your polar form. Okay, now let's do this example here.
You have said to complete how? So that whole thing is a polar form. This all four.
This is your polar form. This is your method to get to your polar form.
Okay.
Alright.
And then once you get to the polar form,
Hmm.
would you have to actually solve this to get a number?
No.
No.
This
That is- that is-
that's your answer.
That's awesome.
Yeah, because you can't get a real number from imaginary number. You know what I'm saying? This here is a complex number
So that's
itself.
R underlined.
Polar form of a complex number. Huh?
Okay.
No, it's just R.
R.
I was just showing you. R says theta.
So it's
Okay.
Wait, English. What is R stand for?
Resultant.
Resultant.
You can see it resultant. It's your hypotenuse as well. Right.
So then what you have to calculate first?
So, the objective is to convert from rectangular. This here is called a rectangular.
Yeah.
Right. Convert from rectangular
Mm.
to polar. I want it here.
That. So you have to use those steps there.
Yeah. All those steps here.
Okay.
Okay.
So yeah.
Right, so I'm only testing determinants and polar forms next week. Oh, sorry, complex numbers next week. So don't stress about it.
Not powerful.
Huh?
So what you're testing?
Complex number is everything.
What problem?
Determinants and complex numbers. Everything in complex numbers.
Hey, we should have tricky first, huh? Looks like. Hey,
Ah,
you
this
know
is,
physics and everything else tricky.
This
Yeah.
is not check this. This
We
is
still passing with sine cos, damn.
this is just trying this. Check is when you come into identities and stuff. That's when it gets fascinating.
So what's this called? This can? Just the angle. There's no.
No, it is trig, but it's
But-
not what we do as trig. You know what I'm saying?
You know, you need to convert that into the.
Yeah, hold on. Okay. Did you all finish all that?
Yeah.
Alright, so see here. I already took my rectangular form, I put it on my Argand diagram. Argand diagram helps us visualize the triangle and to get our resultant, to get our cos and stuff. Alright. So so we got our, this will be 3, am I right? And our B. This will be 2. That's our A. Okay, let's calculate our resultant first. How we calculate our resultant? R squared equals to B squared plus 2 squared. Just taking that there, put it in the calculator.
I need to
13.
get it.
Square root of 13. Okay, so we got our resultant. Check. Now, let's get our A converted into our cos. Right, so we got cos theta is equals to A over R. So first we need to find out our theta, right? Okay, now we find our theta. It's tan theta is equals to 3 over 2. Alright. So theta is equals to tan 3 over 2. Give me theta.
$56.31 degrees.
Any of you
I'm keeping quiet, sir. Now, I'm not gonna. Unacceptable.
Right, so A is 2. And our sorry, we want convert it to A. Okay. So that's it. Let's just do it straight there. Okay, so what is our R? Convert it to
That's equal.
square root 13 cos 56.31. Right. So give me a value of A. Hmm?
1.99.
2.33.
So we can't put,
see where I went.
do we have to leave it as the square root of 13? We can't put that decimal, we will leave it as square root.
You can put it, but it's much neater like this here.
I'm sorry?
It's much neater like this here.
Meter. Okay, so when you're putting that in the calculator, you
Okay,
say
but let me ask you something, right? From this form here,
only the square root.
from this form here,
1.99. Well, actually,
do we have R?
Yes.
Yes.
Do you have the angle?
Yes.
Yes.
We go straight to that step.
We go straight to this. Alright?
Yeah. So what's the point of the other two steps? Oh, you're working it out separately. Yeah, okay. Yeah.
So if I tell you to, so what is our polar form of this here now? In that form there, in the
It will be the square root of 13 and the angle 56.3.
nice, that's your polar form. Now
so how do you work that out?
let's convert this back to that there. Alright? Let's convert it back. So what will our A be?
Result.
Right, so our resultant cos 56.3. Right. We got our J. What will our B be? Will be our resultant
Sine.
sine 56.3. Put this in the calculator. We already calculated A.
That's actually
It's 1.99, which is 2.
No, yeah, it's 2 because it's 1999.
Yeah.
Oh, and that's
So if you round it off,
that's it.
2. And then calculate this here for me, tell me for day 3.
You get 3.
I calculated. Let's let the realization each again.
So we're just working backwards.
Yeah.
To
And then I work forward now. That's how easy it is.
I think maybe slow it down now.
Right, I'm gonna do another example.
Maybe do the steps forward, coming down, and work it backwards again. Like 1, 2, 3, 4.
Yeah. So, see, we do this here. -2 minus 3i. Example. -2 minus 3i. Okay. Right. And -2 will be here. -3 will be here. Okay. That will be our -2 minus 3i. Our point here. There's one angle there, but remember I said the whole angle there. Okay. Right. So we want theta, but we first calculate alpha. Understand it? Right. We're gonna get to it. Just okay. So this portion right here is what? -2 or -3? It's -3.
-3.
Right. And then this portion right here is
-2.
-2. Right. So we got our A, we got our B, we need our R. Yeah, correct. Where are we? Oh.
2 square root 13.
My hands put it spelling now. Right. Because you're squaring the negative. See.
Yeah.
Okay. So we got our R. That's done. Now we need to get our theta. But we can't get our theta because theta does not fall in our angle, in our right angle triangle. So we calculate something called alpha. Right? Alpha. So yes, and we come back. Perfect.
Call it angle 1 and angle 2.
Sounds good.
No, this is alpha. This is what you use here. Alpha. Alpha, beta, but we use alpha to be consistent. Okay? Snacks. Alright. What's our tan alpha?
It's opposite.
3 over 2.
3/2
Minus 3 over 2. Yeah, 3 over 2.
Right.
Cancel.
Give me a tan 302.
Minus.
Okay, but is that our angle theta?
No,
No.
plus 180.
Theta is equals to 180. Why? Can anyone tell me why? Because from here till here it is
180.
180. If it was here,
It will be 180 plus 90.
huh?
270
270
plus.
180 plus
It
90.
was here, but the answer was here.
It'll go all around.
It will be 360.
360.
Okay, perfect. So understand. 56.3. Right. Give me theta.
236.31.
So polar form is square root
That's true.
13 to 236. Sorry. 6.31. Right. That's answer.
Where is 180 coming from?
180 is coming from this here. This is 90. This is 180. We only calculated this angle here because it's in our triangle. We want this entire angle here. So if we calculate this portion, we can just add it to 180 because we already know this is 180. Understand it? Okay. This here is 90. That's 180. That's 0 and 3. That is 270. Okay. So here is 90. Here is 180. If I added an angle here, but I got a right angle there, I can calculate this angle using theorem. Using our trick. Am I right? Shiza? You understand?
Yeah, But I'm asking about if we got data that is 56 point.
No, that's not.
Yes, your angle.
This here is our big angle. Our angle coming from here, going there. You can see, I got this arrow here. Theta is all the way here. Alpha is what we calculated inside. We named it alpha to not confuse us with theta. Understand? Okay, so that's it there. So if you have to work backwards, you can work it out backwards. You come back to the same thing. -2, -3.
So I will be.
Zama, you okay?
Okay, I'm just thinking about backwards.
Backwards.
But,
But you can do a.
but backwards, how would you know if they give you that in the exam now? How would you know about the 50, the angles? That'll be.
Right, no, you just put it straight. Put it straight. So if I work out backwards, it will be cos 23631. It will be j square sine 2631. Okay.
Okay, and what about your minus and would that affect it?
So that should come to minus those
So
numbers.
cos 236.31. So I'm putting a calculation.
So you just have to write the cos and sine.
Yeah, that's what I'm saying. It's
You
easy.
don't have to worry about angles, so not angles,
So that
the
there.
positive and negative figures.
So right now, is this rectangular form? Yes, it is rectangular form, but it's not to its final form. You want it in decimal.
That one there. So you have to work that out. Mine should come to
Yeah, and
minus
then you
2
get
minus
2,
three.
-2, -3. Right, so just
You
put
got
cos,
minus
just put cos
5.5.
But I think it's
minus
wrong.
5.
It's wrong.
What's it?
It's supposed to be I, not J.
Yeah.
Yeah.
Okay.
How much of it?
You have to just imagine like that.
How much of it is market? Right, so if you said square root 13 times cos 236.31, it becomes negative because cos 236.31 is negative. It's a negative number.
So what are you putting in the you're writing cos, the angle.
And then once you get
J.
your negative,
Angle.
you put your negative sign there. You get a negative sign here as well, you change plus j to minus j point, minus 3j. Or minus 3i. Okay, understand it? Let's do more examples. Okay, but before we get to that, sometimes they like to ask this question, so I don't really see the need for it. But when you are calculating the angle, it's called calculating the argument. Argument. When you're calculating the angle. When you're calculating the resultant, it's called calculating the modulus. So I saw in one of the papers they actually said show us how you calculate the modulus. And then everybody was like,
So modulus is resultant.
Argument is angle. I haven't seen it for a while now. But if it's just a term. So they tell you calculate the modulus, and then you're like, what the hell is the modulus? This is the modulus. Calculation the resultant. They don't know what that is. Okay. It's your resultant. When they say calculate the argument, which is your angle, calculation tab. I saw that in one of the papers. If they want to,
Where would the terms come from?
you can,
I'm just saying so we can
Yeah.
understand.
yeah, you can go in your
Some
textbook.
logic to it or something.
You go in your textbook. It just says calculating the angle.
You need to do a easy lesson for now.
No, you know why? So we can figure stuff out because how would you know?
No, I understand where you'd.
Because if you're in the middle of a paper and suddenly you see modulus.
Yeah.
What is the connection?
You wouldn't have seen it for the first time. You have seen it in the textbook. It's in the textbook. But you see, why I'm not going over it
You
thoroughly,
don't think though.
because I don't think it's going to come. But if it does,
Yeah.
that slight chance, a 5% chance,
Probability.
there's a chance. Okay, so there is. Okay, where's your textbook?
So you need to read our textbook properly.
You can read it, but I'm giving you what's going to be bankers. This is your bankers.
This is the last section. Two more.
It's we're gonna go through multiplication and division and stuff like that. Then we got our conjugates in it.
And then exponential rules you'll finish with.
What is it?
You said the exponential laws we need to learn.
That's your homework.
Yeah, you'll finish. There wasn't.
I'm
No one's asking how I understood it. I'm saying that we won't be.
not gonna test you. I just want you to.
Okay.
So wait, let me see looking for this one. Yeah, check it. Addition, subtraction, complex numbers. This is how they prove it. On page number 57. You can go to that, but they will not test this exam. They will not test.
So no,
You going into geometry over here.
Yeah.
That is not engineering. We don't do
too much work.
Yeah, we don't design bridges and stuff like that.
Why is it?
Mathematics is more related. engineering, civil, all of you see. So they just teach you. So this year, yeah, so you see, if someone was doing mechanics, mechanics student will be sitting in the last 2 minutes. Understand? So just like our campus is to fuse all our classes together and make it civil, mechatronics, everything for maths, engineering, science, just we always manage.
This is how higher you start branching off.
The same.
That's the
That's fine. Okay, I'm gonna wrap this up. Remember, make your definitions. Modulus, argument. Okay. Calculating R is your modulus. Calculating theta is your argument. Okay, let's do examples. What's the level of difficulty about just to be hard? Yeah, like that.
We rather know now.
I'd rather kill you now when it comes to exams. It's nothing, right?
Yes.
Huh? What should I say, girls? Oh, yeah. I'm not even worried. Extra hard for them. First, level of the chest. Easy, medium, hard, extra hard. Oh, yeah,
Extra hard.
But now the mark is going towards now. No. Yeah.
I'm just, if you want more practice
Now,
and you're confident in yourself that you're going to
give us the level of the exams.
Correct. Yeah.
Exam
That's
level.
We don't want easy,
exam
we don't
level.
want.
So exam level doesn't fall with easy, hard, extra hard. It's exam.
Yeah, and you know it, so
You know what
like
to-
it.
yeah.
So we know what to expect.
So just a little pleasant for you. Whatever we did in determinants, in the last questions you're doing determinants, same thing, same level you see in the exam, in the test.
And the test. Exam.
Okay, so aren't you comfortable with that level of determinants?
Yeah.
Alright, because that is the exam level. It's not extra hard, it's exam level. Okay, so if you're comfortable with that, and you get comfortable with complex numbers the same way as I want to do it then, it should just, exam level should be easy. Exam level is how you class it on that range. You understand? So if you feel that section is hard, the exam level is going to be extra hard. If you feel that section is easy, it's going to be easy. Right, so that's why I said exam level is hard. You take it where you want to do it. All depends on you.
You decide.
Okay, let's work backwards. So the class exercise. Convert to rectangular.
Okay, let's see.
Right, so let's do this. Right,
What is that thing on bottom?
It's pi.
it's fine.
Hi.
Fine.
This one.
Same.
Right, so I feel like 90% of y'all will get this wrong.
Nothing.
90% of y'all are going to get this wrong. Let's see who's smart enough to get this right.
Chance exceptions.
Yeah, okay. So see how everybody can get this right. But here, I want to see what you can get.
Yes.
We both have.
Huh? What's that mean? What you mean? You don't know the value of pi? Yeah, 3.14. It's on your calculator. No, it's on your calculator. The calculator will give you the continuous one. Right, 10 minutes to finish that up.
You're gonna go now from that now. The other, you have to work backwards now. So you're gonna work backwards, so it'll be 3 cos of pi
Oh,
plus 3 sine of
oh,
pi over
3
4.
cos the angle.
Yeah, but then you have to work it out. Yeah, then you have to work it out to go now to in back to that other form. -2 minus 3. Okay, let's just you should have started on. We kept that last. Yeah. No,
No,
because
because I don't want
because
to
this is what is not.
not.
Remember we said the result is equal to whatever. You can work out square root of 3, but just let the square root of 3. Right, so that one here will just be 3. You understand what?
Right, first one.
No, wait, no.
No, I didn't.
Our conversion is in one step. Guys, come on. This is calculator work. Sharp, come on. Huh? Don't have calculator? Oh, shoot. Okay, just move with Kaya.
Yeah.
So if Kaya calculates it, you do that.
Wait.
Okay, let's not calculate 1 first, calculate 2. Let's see who can do that.
Yeah.
Should have been done. Should have been done. Huh? For this one, yeah, I know you're going to get wrong, so that's why I said I'll just go to the easy one first. Yeah. But it's one step, guys. Remember, see, just like how I did that there.
Yeah, I got 3 then.
You got 3.
Yeah, 3.04. I don't know.
See now?
I got 3 plus
Convert to rectangular.
sine pi over 4.
So the top like -2 -3.
Yes, that's your rectangular form. So you're calculating your A first, calculating your B. See, just like how I did this here. This is my polar. I'm calculating it to rectangular. This is the first step to getting into rectangular. You convert, you take your R, you multiply by your cos, your angle. That is A. Next one, R times your sine, your angle. That is B. And then as soon as you put this in the calculator, you got A. As soon as you put this into the calculator, you got B. Done, 3 steps. That's why I said it'll be under 10 minutes. You're not taking the question, huh? Convert your rectangular. See, Bilal is crashing anywhere.
I don't know, I'm just doing my own thing
Hey,
here.
what should you do that?
I don't know. This I got here. That's the other.
Yeah. And this should be
That's
only 3 steps. How much is this?
I'm trying to work it out now. This part should get into the other form. -2 -3. Yeah. No.
Okay, this is the only step that needs method. This and this, the final answer is just calculator work. There's nothing to convert pi or anything. You put pi in the calculator.
Okay, so I do it.
Yeah.
So it's 3 plus.
So I want decimals now.
I didn't think you wanted decimals. I thought you wanted
Okay,
fractions.
complex numbers they always like it in
Decimals. Okay, then.
only in polar form you keep it with the square root and stuff. Only in polar form.
Okay, then change it now.
Yeah.
They don't fractions either.
Convert it.
Okay.
Convert from a fraction to a decimal. But this here is fine. This you got it in the right form. But
That is fine.
yeah.
That's why I
If it looks like this, yeah.
Okay.
Hey, it's just calculator work. So you feel? Yeah. There. 2. There. I don't know. I like the method. I'll give you mark for the method. Here. Getting 0 then. Okay. Let's work with 2 first.
No, I didn't even do the part.
She's waiting.
I'm waiting.
Because she knows. I shouldn't have said that. She just took that.
She wants the art paper too as well.
Okay, I'm just going to do 1.2. You got 2 cos 315 plus j through sine 315. Right, give me this answer here. Give me 8. It's square root 2. Everybody else got square root 2?
Yeah, Bob.
Right, square root 2. But can you give it to me in a decimal form? Square root 2 in a decimal form? 1.41. Anybody can verify?
Yeah, Bob.
Yes.
Right, now give me b. 2 sine into 3 or 3 or 5.
Negative square root 2.
Negative square root 2.
Yeah.
Right, so it will be negative 1.4.
I thought you looked at me and said I said I'm going wrong, but I got it right. How wrong? So I'm not reading it right. I thought I'm doing it wrong.
So can you I?
Fine, okay.
Wait a minute.
Okay. Who tried one notch?
I don't.
Well, I got an answer.
Right. Let's do 1. So it's going to be 3 cos pi over 4 plus j sine 3. Sorry, 3 pi over 4. Right, what's 3 cos pi over 4?
299.
3.
3.
3.
You can round it off.
You have to round it off because it's 2999999.
No, this is That's it.
If you round up to 2 decimals, it's going to
What's this, guys?
B.
What's this?
Fraction.
It's a fraction. Okay. Right. Would you say it's the same as this here? An angle. Okay, so in mathematics, right, in metric, there's different ways to calculate angles. Right, there's one called degrees, and you see on your calculator a small d on the top there.
Yes.
Right. And then when we come to trigonometry and stuff, in metric, there's something called
Radians.
radians. Right.
Okay.
So when we are looking at something with pi in it, so I want you to go back and see what pi stands for, what 2 pi stands for. Okay. Right. When we're looking at pi over something, or anything that says 2 pi, we do not work in degrees anymore, we work in radians. Right. When we see this here, it's degrees. When we see pi over anything, 2 times pi, pi divided by it is radians, but you never get pi divided, it's always pi.
We've changed more calculator.
So on your calculator, you need to change your calculator to radians. And how do you change it to radians? Shift, mode, radians. It will be 3 or 2. Give me the number. 4, okay. Change it to 4.
Yeah.
Right. Now you say 3 cos pi over 4. You should get 2 point.
Oh, so you knew we were going to get it wrong.
Yeah. So 100% of it. I thought maybe 1% will remember.
Can you repeat that?
Okay, shift,
Yeah.
mode.
You were
See
calculating
right now.
for physics, we're going back the right mode.
Oh gosh.
Okay. So you see there's a D there. That means it's
2.1.
2.12. Yes, that's correct. Okay.
Yes,
So you say shift,
answer the right mistake.
mode.
No, I just That's it.
Yes. Okay, shift, mode, and 4.
Yeah.
3 is degrees, 4 is radians.
Yeah.
Now you say 3
You change it up, page 4.
cos,
Okay. It's a.
not to be pi, say shift pi, shift times 2. Okay, over 4.
So, in engineering science, we're supposed to be using this.
No.
That's right.
That's right. Yeah.
Now we're going to
Understand?
Just that when we do gradients here for complex numbers,
You just switch
So,
the
we see
calculation,
pi.
but you also switch that when you do.
So how do you shift between the gradients? Shift mode. You have 3 is going to be gradients. 4 is gradients. You press 4 here. Right. Now anything that you work out with pi will turn it into the correct answer. So you see 3 cos. Fraction. You see pi. You see the shiny pi sign here. Shift pi. Equal 4. Right. So one of my chart here was if 90% of your fail, you fail the top part, that's fine. The other 10% who got it right and changed the calculator to radians, I wanted to know if you were sharp enough to change it back to degrees when you were working on this here. Because if you worked out cos 315 in radians, you'll give it the wrong answer.
We never change calculators.
So I had you all check both sides.
Yeah, but you should have told us, and you
Oh,
should have
yeah.
give us another example and tested
It's,
us.
it's like a Sophie, I'm giving you a little bit.
We learn more from the mistakes
I'll
that
tell you where, I'll tell you there's a dead body and I'll tell you where, but that's alright. Okay, so do not make the mistake. See, this is how examiners think. They're thinking like me. Right? They will give you pi. And everybody will sharp enough to know change your calculator radian. They keep giving you pi, and then straight away they give you a degrees, and then in your mind it's like, just put in a calculator. You're gonna get it wrong. You get the entire thing wrong. You may get that first step right, because you wrote it down. The final answer is going to be wrong. Alright, this is the way they think it. They're setting traps. They want you to fail. They need that rewrite money. Okay? This is what happens. So remember, as soon as you see a pi, change it to radians. Only for complex numbers. Okay, as soon as you go back to a normal degrees, normal number, change it back to degrees. Shift mode 3 will give you degrees. Shift mode 4 will give you radians. Okay? Right.
Wait, you must change your calculator. You can't just put in max mode and hit number 1. That's normal mode.
Yeah, you put it, normal mode is degrees. Standard is
Not
degrees.
that's degrees.
Yeah, can you write them?
Yeah, yeah, okay.
I'm putting in maths mode.
Okay, how was that? Yes?
No, but say now.
Those should be in number 3. I was always number 1.
Yeah, that is a angle.
I'll go back.
So when you're using this here, use it in degrees.
So when you're done, just find like go to 30.
What is what?
No, see, what's the question? The question was convert this to polar. That's your answer there. Right.
I didn't go back.
Yeah, stop there. Now, if I tell you convert this back to rectangular, this here, you do all this here, and then you get -2 here, you get -3, -2, -3i.
I'm thinking like how
Yes, yeah.
Remember, I said
Yeah.
this is basically the same as. Am I right?
how you put cos
That's
But
cos,
18 is
that's your j, and that's your sine. And then you put this entire thing into a calculation, you get -2.
It's supposed to be mode 3 all the time.
You get -3. Understand?
Yeah.
Okay, let's do.
When was
So
the
number
mode 1?
one is what?
So yeah. So
Where's point 1, 2? Plus, okay.
oh, yeah. 2.12 plus 2.12. Okay.
J goes down the side.
Does it matter which way? The J.
You put the j here and you put 2.1 there, it's fine.
No, I mean that was going before or after 2.12. Right.
Oh no, yeah, multiplication, anyway. As long as you know this is A, this is B. Right. Good stuff, right? Let's see. Let's go back to. Can I take this out? Yeah. Touch on something valuable today, guys.
No,
Please
no.
remember it.
I'm running my 450 something different modes and all that. So
We actually use it. But if you're a mathematician, you use all modes. Engineering, we use just a few. Okay, here's an exercise. 2 plus 4i. Okay, this here I want it from rectangular to polar form. Okay.
Is that minus?
Yes.
Yeah.
Sorry. Yes, it is.
That's number 3.
Hmm?
No, it's fine.
Isn't it?
I'll also get number 3.
Oh, the same as the other one, huh? Yeah. Yes.
Something. Oh,
So what number is that?
that's 3 now.
Change that
No,
to a
it's
3.
Yeah. Okay, whatever you don't finish today, you can finish as homework. You've got a nice public holiday. Don't worry about your family, worry about maths.
Tomorrow you're not coming, what?
I'm not going to be here.
That's nice.
Even if you're here. You won't see me.
That's nice.
I'll see you on Saturday, bro. We'll go over all of this if you're right. Okay, yeah. Since it's almost the end of the lesson, if we have time, we can finish unit 1. Rest of it, we'll do it on Saturday.
with the plus and minus, that the previous one we did, yeah. It was 1.4 minus j, right? Because the other one was plus, right? Is that because of the angle?
Yes, so sometimes if you put an angle into sine and cos,
Yeah.
you get a negative value. So say if you see we had 2.36.31 in cos, that was positive, but in sine it was?
Yeah.
No, actually it was actually negative in both. So it will be negative the entire. That changes the signs, the negative. So how you work here out
So
is,
how can we go? Okay, then.
so how you work here is you keep j on the outside,
Yeah.
whatever number is here, it will be a negative. Right?
Yeah.
And then j is positive, negative times positive, it becomes negative beta.
Okay.
Understand?
I think the first one will stay also.
This here is if you put this entire thing into the calculator, actually,
Yeah.
you get a negative answer. You get
So
negative,
We
you
want
get,
to be negative.
yeah, you get negative 2.
Okay.
And that becomes negative.
But it's basically because of the angle.
Yes.
The angle is more than what goes into the negative then.
Yes, yes. That's why I say don't worry about looking too much with your own self. bring it down to that point right there.
Yeah.
Shove the entire thing into your calculator. Well, not shove the entire thing. Take A, put in your calculator. Take B, put in your calculator. 3 marks, yes.
3 is 60, is the same as 3, the same as slightly bigger. 3.
Yeah. Cis is the same as this. Cis is the same as this. That's the same. Right, so you know the last one what to do. I never said to the chaps already to I had my fun already, so. Check out. No, so you can do this homework, that's all. Okay, that's all.
Yeah, I think we'll do that one
Good enough.
short break.
Right, in with the second lesson.